Yo, Algebrainiacs, here we are. Johnson Kendrick Video Hour.
But it's not an hour.
Not an hour, but maybe it's a half hour. It's part two.
Yeah, maybe.
Was part one a half hour? No, not quite. Oh, cool.
It's a rational expression. Model.
Nice. That goes on what we're doing. Now, today we're doing complex. Now, we're not going to try to give you all a complex. But complex means it's a little more complicated. So
Okay.
if you read the definition there, they're rational ratio expressions that have at least one fraction in its numerator, denominator, or both.
So it's a fraction and a fraction.
Oh my.
All right, so you need to remember one thing, and I believe it's from 5th grade math or something.
Yeah.
Dividing by a fraction is the same as
Multiplying by its reciprocal.
Okay.
Phew.
Here are your steps. Go ahead and hit pause, copy those down.
Oh, time's up. You heard the bell. No more writing. Put your pencils down. Just kidding. All right, let's keep it going here. Oh, that's scary
It's
looking.
complex.
Woo!
All right.
So we gotta treat it like the top is a separate problem than the bottom. Start, I think.
Yeah. So look at this. This is easy.
Woo! Yeah.
So we're going to spend our time working down here. So in
Okay.
fact, we're going to almost ignore. In fact, I want my box back. Here.
Cool. Alrighty, so 1 over x plus 1 over y. They're not the same denominator. We can't add those.
Okay, so let's find common denominators. What would the least common multiple be?
Probably xy.
Okay.
Multiply.
So I'm going to write a little note on the side. Least common multiple or least common denominator would be xy. So we need to turn both of those into xy.
Well, the first one needs a y.
All right, and we can't go around just multiplying by y. We got to do
Use
y over y.
1.
Yep.
Okay.
This guy is missing x.
X over x, another 1.
Okay, so I'm going to rewrite it. Now it will say y over xy plus x over xy.
Well, now they're the same. We can put them together.
Okay, so can I do alphabetical order to save my brain?
Oh, yes. Okay.
Okay, so I can cancel those x's, right?
Oh, no! Just kill the kitten.
So I can't do that?
Poor little kitten.
Why?
Because it's got a plus sign. X plus y. I don't know what that is.
Okay,
I can't cancel that.
okay. Whoops.
Holy moly.
That's a different worksheet. We're not doing that. That's IB math.
Here we go.
Okay. So now, don't forget.
X is still at the top.
Okay, so we're at this point. How do we handle a fraction and a fraction again?
Well, I like to make them both fractions because then we can flip them over and multiply straight across.
So our x in the top really has a denominator of 1.
Right.
All right, so I'm going to rewrite down here because we're running out of room.
So x over 1 is
X
good.
over 1, and we're
Now-
going to change it to multiplying.
Invert the denominator.
Oh, so flip.
Flip.
Anything that has addition, I'm going to recommend some parentheses
Good recommendation.
so we don't kill kittens. All right, so multiplying straight across. I can multiply that because that's all multiplication. If that were addition up there, we'd have to distribute. So what does our numerator become?
X squared.
Uh-huh.
Y.
Oh, okay. Denominator 1 times x plus y is just x plus y. Can we cancel anything?
No!
Because we kill kittens. Don't do it. By the way, we don't have to do restrictions here because our book is nice.
Nice.
Because there's a lot.
Yeah, true.
Well, maybe
Yeah,
not.
x can't be 1,
Negative
y is
y.
negative 1.
Yeah.
So we have two variables. They can be just about anything.
X can't be 0, y can't be 0, x can't be negative y can't be negative
Yeah,
x.
but it's lots.
Too many. So what am I doing? Just,
No, you can't divide by 0.
do you feel comfortable with that one?
Yes.
All right.
I don't have quite a complex yet.
I thought you
Oh, now
you
I
might
do.
now, though.
Oh, goodness. So let's, break it into top and bottom
All right.
first. All right, common denominator. This is like what we did in part 1.
Okay.
So we have an x and an x plus 1, so we need them both.
X plus 1 is common
Yep.
denominator.
So the first one we need x plus 1, and the other one we need x plus 1.
Have to use a useful form of 1. And this one we need just the x,
Yep,
correct?
yep.
All right, so I'm going to multiply those. I'm going to FOIL in the top, but not in the bottom. I'm also good at this because we have a day of practice under our belt, so I know the common denominator is that.
Yes.
What would we get if we FOILed these two things together here?
That first one's in parentheses, right?
Yep. Oh yeah.
So
Yep.
make sure we remember that. All right, so x squared, and then minus 2 and a plus 1 would be minus x,
Okay.
and then negative 2 minus 2.
Okay. Now this is now plus 2
2x.
2x.
Now, I can put those x's together, so x squared plus x is minus 2.
All right. I do recommend something. Guess what it is?
We gotta factor the top.
Just see if maybe something could cancel. So what would it, can you factor that?
Yeah, plus 2 minus 1.
Oh, so nothing cancels.
No, so we can leave it in any of those forms, right?
Yeah, in fact, I think it might be better for us to leave it factored because eventually we're going to deal with that denominator that some of our
Oh,
students
yeah.
maybe forgot about. But
I kind of did.
yeah, so there's this huge fraction bar.
Okay.
So let's deal with that denominator now.
All right, same
Process.
deal. We have x plus 1, so nice.
Missing the x
Yep,
over x. Got to use useful forms of 1. Missing.
x plus 1. Okay, so the top left is 3x plus 3.
Oh, because you distributed. Okay, 3x plus 3 minus.
Let's do it all at one. Yeah, minus 1x. And then x plus 1.
Can we simplify anything there?
Yeah, we get 2x plus 3. And x plus 1.
Okay, so don't forget, we're at this point. I shouldn't put a box chart because it's not our final answer, but that's where we are,
Okay.
and we're dividing a fraction by a fraction. So again,
So
how
this
did
is
you
where
handle that?
we make sure they're both fractions, which they are.
Yep.
And then we flip the bottom one over and multiply straight across.
Okay, so our first fraction, I'm going to use the factored form, x plus 2x minus 1, you said.
Mhm.
The denominator's not changing,
So that's just the top.
but the second fraction does get to change. So it flips over.
Put the bottom on the top.
X plus 1 and
3.
okay, now if you have all multiplication, which we do, this is multiplication, it's not addition, you are allowed to reduce.
I see we can cancel the x's and the x plus 1.
So we're not killing kittens because it's multiplication.
Right.
So the numerator is
You're really just taking out the useful forms of 1.
right. That's a great way to think about it. And you know this can't be factored, but you would want to check to see if maybe it could, because maybe more stuff could cancel.
I love crossing stuff
Me
off.
too. It makes it feel so good.
Ah, kind of like a checklist. Done. All right, well, whew. Now I kind of noticed that these two are the same,
Uh-huh.
and they ended up crossing off.
Mm-hmm.
Is that always going to happen?
No.
Well,
Parts of them, though.
Yeah, unless they're exactly identical.
Yes.
And what did we end up with? We ended up with this over
The
this,
numerators.
which is just what we had here.
Interesting.
These are both numerators because the denominators,
We're this
We're
exactly the same.
they're not exactly. If they have one piece that's a little extra, you can't think of it that way.
But just keep factoring and see if stuff cancels, because you'd be amazed. A lot of times
I'm already amazed. Look how cool that looks on there. We look so smart.
we are.
If your little elementary sibling looked at that, they'd be like, whoa, you're a genius.
Are we gonna make this one an hour?
Yeah, we could talk for another 40 minutes, 51 minutes. All right, ta-ta for now.